please.
Yes. Wait, something that multiplies to 16 or negative 16
Negative, yes.
adds to 6. Okay.
Positive 6. So obviously one is positive and one is negative in this case. And you'll have to work through those and you'll find it pretty quickly. I mean, there's not a ton of these that work.
Oh yeah, so it would be 8 and negative 2.
Yes, so there would be x plus 8, x minus 2, but we're not done. But go ahead and get that down.
Okay.
So you have to set each of these, each of these equal to 0. So you set x plus 8 equal to 0 and x minus 2 equal to 0.
Okay.
And then you just solve, for x.
Yeah, so then x would be negative 8 and x would be positive 2.
Yes.
Okay.
Okay, so let me give you another one to work on here. That's okay.
Yeah.
All right. I apologize. Like as soon as we started the lesson, I just sort of got sleepy. I know as a student that happens when you start to study, but it's not supposed to happen to me. All right, let's look. X squared plus 7x minus 18. Go ahead and do the same thing for this one, please, and let me know what you come up with.
So I got x equals negative 9 and then x equals 2.
Yeah, that sounds right. So you set them both equal to 0. And then you get, like you said, x equals negative 9 and x equals 2. Perfect. Okay. What else do you have for us to look at that you know is a good question you might have on the quiz or test?
Yeah. We can do one that says solve for y.
Okay.
So it will be in parentheses y minus 2 squared.
Okay.
And then plus 3 equals 28.
Okay. This is a good problem for us to do. So the fact that you're solving for y really isn't important. It should just say for the variable. Notice there's only one variable. Only one variable. Okay. In this case, you almost always use the square root property. Okay. So you're going to subtract that 3 from the other side of the equation. And so you get y minus 2 squared equals 25.
Yeah.
So now you're going to take the square root of both sides. And this is a critical step. This is the one where most students make the mistake of not putting both solutions, plus or minus. You want to make a mental note of that or somehow say, okay, I got to remember to do that.
And you only do plus or minus in the equation whenever it has the square root of something?
With square root, yeah. The plus or minus goes with the square root. It's really a shortcut to something else that you're doing, but we'll just go with this. Actually, so anyway, so the point is there's really two solutions. And if you remember what a quadratic looks like, it's something like this. So that there are two solutions where it hits both times.
Yeah.
Okay, so that's plus or minus 5. And then you add 2 to both sides. And I prefer to add the 2 in the beginning. So it's 2 plus or minus 5. And that's really 2 plus 5, 2 minus 5, 7, and minus 3.
Yeah.
So, all right, so is that okay?
Yeah.
Okay, so let me give you one to try. That's gonna be really similar. Let's say it says, let's go solve for P. Let's go P minus 3 squared equals, let's go -9 equals 27. Go ahead and try solving this on your own, please.
So it would be 9 and -3.
Yeah, that sounds right. Let me just work it out here. P minus 3 squared equals 36. And then you take a square root of both sides. Plus or minus square root of 36. So P minus 3 equals plus or minus 6. 3 plus or minus 6 is your P. So that's, yeah, like you said, 3 plus 6, 3 minus 6. And you do have to write them out separately when you actually have them like that. Okay, great. So what other questions do you have there?
There's a factoring one right here. It says 6x squared plus 7x equals 3.
Like this, 6x squared plus 7x
Yeah.
equals 3. Okay, great. So first thing you want to do is get everything on one side of the equation. So you're going to subtract the 3 over. Okay, now this one's different. This one is you have to, I assume you've seen this before. I think we covered it, but you have to multiply the 6 and the -3, and that gives you -18. Okay, hopefully you've seen that before.
Yes.
You're looking for two numbers that multiply to 7. So you can either make your list like I'm doing, or maybe it just jumps out at you. But the answer is -2 and 9. Okay, these are the ones that work. So you're rewriting 7x as -2x plus 9x -3. And the order does not matter, but you kind of look for like, okay, 6 and 2 go together. 6 and 9 also go together in terms of like factoring. But sometimes there's one that's like a little better than another here. So you now look at the first two terms. Okay, and you ask yourself, what can I factor out of both? And that's a 2x. So that becomes 3x minus 1. And then you immediately write it over here on the right, 3x minus 1. And what you're hoping for is there's something you can put here such that when you multiply in, you get 9x minus 3. Do you see how that's plus 3?
Yeah.
Okay, so you have to figure out that number. That's a guess. You don't, there's no way to know it if it works. So then the final step, I like to call this double factoring because you got to do this twice. 3x minus 1, you factor out of both. And what's left over? 2x plus 3. You set those both equal to 0. Actually, this one just said to factor.
Yes.
Just factor. Okay, so we are done. We are completely done at this step.
Okay.
Okay, so let me find another one like this. Sorry, I don't have these just off the top of my head. I have to actually look up some because they're.
Well, it actually says solve each equation by
Okay.
factoring.
Okay, that's important because we need to keep going. We need to set each of these equal to 0.
Okay.
Okay, so these are called two-step equations because you have to do 2 steps, and you're either adding or subtracting and then multiplying or dividing. So like on the left here, you're dividing by 3. On the right, you subtract 3. then you divide by 2. Sometimes you get fractions, sometimes you don't.
Yeah.
Okay, so let's try another one of these. Let's go and just check that this actually is right. 2x squared minus 5x equals 3. Let me just check this one real quick. Yeah, this one works. Okay, great. So what is the first step here? We'll work this out together, but what is the first step?
You move the 3 to the other side.
So do you add or subtract it?
You subtract.
Yes. I'm just asking for clarity because
Yeah.
Okay. This is because there's not a 1 in front. This is when you have to multiply the first number coefficient and the last number. So you multiply 2 times -3 together, and that's -6. And then now you're looking for two numbers that multiply to -6, but add up to -5.
Yeah.
And
So
I'm
it's
just listing them. You can either just list them or you can just come up with the one. Doesn't really matter. But what is the correct one?
6 minus 1.
The 6 has to be negative because it's -5. So yeah, they give if the -6
Oh,
plus
it's
a 1.
-5.
Yeah, sorry, I didn't make
Oh,
that
no,
clear.
so
Okay.
at least it'd be -6 and 1.
Yeah, and so the order matters here. Is it -6x plus 1x, or is it 1x plus 6? Sorry, -6x. Which one is it?
Is it -6x first?
I like that one better. I just feel like it goes better with the 2x squared. It's not really a wrong answer, but there's maybe one that's slightly better.
Mhm.
Okay, now look at the first two terms. What goes into both?
2.
More than 2. What about x?
Oh, 2x, yeah.
2x. Okay, so then what goes in parentheses?
X minus 3.
X minus 3. And then x minus 3. Okay, now we got to figure out what goes here such that when you multiply it in to x minus 3, you get back to x minus 3.
1.
1. Okay. And then now you have to factor out again whatever is common to both. You see how the x minus 3 is common to both?
Mm-hmm.
So that comes out. What goes inside parentheses here? What is left over?
2x plus 1.
2x plus 1. Yeah. All right. So go ahead and set both of these equal to 0 and let me know what you come up with for your final answer on that, please.
Okay. I got x equals -1/2 and then x equals 3.
Yes. Okay, so let me have you try one on your own, completely on your own. And this isn't any harder or anything like that. Maybe hopefully it doesn't look any harder, but we'll just go equals 8 for the moment. Yeah. Okay, so same thing. I'd like you to try solving this and see what you come up with, please.
Okay. I got x equals 2/3 and then -4.
like this?
Yes.
Okay, I think that's right. Let me work it out just in case you want to see the steps later on. So it's 3 times -8, which is -24, and so it ends up being -2 and 12. So I'm going to go 3x squared plus 12x minus 2x minus 8. Is that the direction you went on this?
Yes.
Okay, so then we factored a 3x from both of these, x plus 4, x plus 4, minus 2 plus 4, x plus 4, 3x minus 2. Yeah, looks perfect. Those produce that. Okay, very good. What else you got for me?
Let me see. But we can do a completing the square one.
Okay.
So it says x squared plus 4x plus 3 equals 6.
Okay. Good. Okay, we actually have not looked at one like this. I mean, it's not any more difficult or not, but you're going to start by subtracting 3 from both sides because you want a bucket or a placeholder there, and you want anything that's constant wise to be on the right.
Yeah.
Okay, now do you remember what goes in parentheses down here based on the 4?
It's half of 4.
Yeah, so it's x plus 2 because this is plus. And then when you square, you go back. So 2 squared is 4, but you have to be fair. You have to give it to both sides of the equation.
Yeah.
Okay, so this equals 7 on the right, and this is now the square root property. Remember we did a couple of those earlier. There's only one x, so it's a square root property. So you take the square root of both sides. This time, though, the right side is not a perfect square. Okay, but it's still plus or minus.
Yeah.
Okay, so unfortunately, like it's like not friendly, it's uncomfortable, but it's just the square root of 7. There's nothing more you can do. So now you're going to subtract 2 from both sides. So that just goes up in that position. So x is -2 plus or minus the square root of 7.
Yeah.
Any questions on that?
No, I got that one.
Okay. All right, so let's have you try one here. Completing the square, I'll give kind of the same difficulty. Let's go x squared plus 6x plus 7 equals 9. So give that a try, please.
So is it x equals -3 plus or minus square root of 11?
You got to subtract 7 from both sides, right? And I think you did that. Then you got 2, and then you said 11, right? I'm sorry, I almost didn't hear what you said.
Yes,
Yes.
11.
Yeah, yeah, that sounds perfect. Let me just get the steps here in case you want to look at these later. Yes, that sounds exactly right. X plus 3 squared plus 9 plus 9. Like that. Now, we have not, I think we talked about this. Some teachers are fanatical. They're like, it must be in this format, and they're not wrong. You know, they have their preference. You know, if it's a test, give them what they want. Like you don't win anything by, you know, arguing with your teacher generally. So if they want it in this format where they're separated, you just do it. You say, okay, Mr. Teacher, you know, here you go. And it's a small thing, but it could, you know, could make the difference between like an A and a B sometimes, stuff like that. Okay, what else you got?
I think that's all. If you have any like old
Yeah,
things or anything like
yeah.
that.
Let me just pull up a question or two. I mean, we don't have to go. We can go, you know, as long as we need to. But let me sort of give you a question from each grouping, and you can say, "Oh, I have no idea," or "I got that," and we'll go from there. So let me give you a graph here, and how many real solutions are there?
2.
2. Great. Okay. If it touches, how many solutions are there?
1.
1 real solution, yeah. And then if it does not touch, do you remember what this is called or how we refer to this?
Isn't it imaginary?
Yes, 2 imaginary solutions. Good.
So how do you know it's always 2 instead of like 1 imaginary?
That's a good question. We can't answer that in this class because it's in the, so you can take an entire math class in the complex world that has different rules and things like that. You play sports, right? Or what, remind me what sport you play?
Volleyball.
Volleyball. Okay, not a good example, but I was thinking of something that shares, you know, but it's very different. Yeah. Well, so in reality, there is, and this is not correct, but there is a complex coordinate system where it does hit.
Yeah.
It's way outside the scope of this class, and I think it's a reasonable question to ask. It's like, hey, if I can't see them, how can they exist? Yeah, it's not worth spending a lot more effort on that, if that's okay.
Yeah.
With you. All right. So that page is knocked out. Okay. We started last time where I know you were like, hey, can you give me a problem with some in the form A plus BI problems?
Oh
So
yeah.
let's do a couple of these. Let's go square root of -36 minus the square root of -49. Okay. Do you remember how to do this?
I think so, yeah. So it'd be -6.
So be careful. It's the square root of -1 is I. So let's just say it was the square root of -4. This is the square root of -1 times the square root of 4. The square root of 4 is 2i, 2i. This becomes 2i.
Okay.
Okay, so it's not negative. It's so this whole thing makes 6i.
Yeah.
But the one to the right, because there's a negative sign in front, it will become negative, but it's yeah. Well, so what is the square root of 49? Let's try that.
It'd be 7.
7i after that. So and then you just treat these like they're x's, you know, 6i minus 7i. That's -i. Or -1i.
Yeah.
Okay, let's try another one here. Let's go negative square root of -100 plus square root of negative 25 plus square root of negative 81. Go ahead and try that on your own, please.
Is that a 75 or a 25?
I'm sorry, 25.
Okay. So it would be negative 10i
That's right.
plus 5i plus 9i.
Okay, I agree.
And then it would be 4i would be, I think, your final answer.
Yes, 4i, perfect. Okay, let's go back briefly to a problem like this. 6 minus 3i minus negative 3 plus 9i. And this would just say to simplify. Do you recall how to do some problems like this?
Yes, I do.
Okay, do you want to give this one a shot, or do you want me to show you how to do it?
Maybe you should do one first.
Okay, so the key here is to distribute the negative to both terms. Okay, so on the left, the parentheses are no longer needed. Plus 3 minus 9i. Okay, so that's 9 minus 12i.
And that's just your answer, and you have to leave
That's it.
A plus B.
A plus bi form. Basically, it's got to have a number and then the operator and then another number and then I.
Yeah.
Number, operator, number, I. You distribute in, you combine like terms. There's nothing more to it than that. Okay. So let me give you another one here to work on. Let's go negative 4 plus 6i minus 7 minus 8i. You want to give that one a try, please?
Okay. Could be negative 11 plus 14i.
Yes, perfect. Perfect. Okay. So the next type of problems I'm seeing are sort of these like FOIL problems. So let's say it's like 3 minus I times 6 plus 2i, something like this. And it just says to simplify, but what they really mean is to FOIL. So FOIL means first, outer, inner, last, and it's referring to the, the terms that you multiply. So the first times the first, outside times the outside, the inner times the inner, and the last times the last. Okay, and you've seen that before, but let's do it one at a time. So 3 times 6 is 18. 3 times 6 is 18. And then the outer is 3 times 2i, so that's 6i. The inner is minus I times 6 minus 6i. Minus I times 2i is minus 2i squared. Okay, and you might feel like, okay, I'm done, I've got it, I'll just combine like terms. You have to remember that I squared is -1. I squared is -1. So kind of like the last problems where square root of -1 is I, you have to remember, let me actually write that here, boxing, in case you want to look at that later. You have to remember this I squared equals -1 for your FOIL. So what does that mean? It means that wherever you see an I squared, you're going to put a -1. You can combine these actually cancel out, strangely. 18 plus -2 times -1 is 2. 18 plus 2 is 20.
And that's it.
That's it. Now, I didn't mean to choose one where the I terms canceled out. They don't normally. So I'll give you one here where they don't, but you've got to be comfortable with FOIL. And you've done it before based on the class that you're in. So this is not a new thing, and you may just need a reminder on how to do it. So let me give you one here. Let's go 2 plus I times 4 minus 3I. Why don't you try that one on your own, please?
Okay. So it would be 11 minus 2i.
11 minus 2. Let me take a look here. So we get 8 minus 6I plus 4I minus 3I squared. So yeah, that gets you the minus 2I. Minus 3 times the minus 1 is plus 3. And so that goes with the 8. That's perfect. Okay. Just one other small little wrinkle. You should be comfortable with it, but I'll just throw it out for this. Let's say you have 6I times -3 plus 4I. So this time you're taking the 6I and you're distributing it in to the two terms. It's kind of like FOIL, but without part of it. Minus 18I plus 24I squared. Just distributing in. I squared is -1, so you have to make that substitution. Okay, so if you're at this point, okay, and you write this, you might get marked off because it's not in the A plus BI form. So you just have to switch the order, minus 24, minus 18i. You're not switching the numbers, just the order. Be like you and your friend in volleyball. I know you guys rotate. That's all you're doing here, just rotating.
Yeah. All right.
Are you an overhead serve? Is that the standard at your level, like smash serve?
Oh yeah. I've been playing volleyball maybe like 8 years.
So you're kind of a big deal in volleyball. That's what you're trying to say.
Yeah,
Okay, that's awesome. That's awesome.
yeah, it's just like been basically my entire life.
Okay, that's cool.
Yeah.
It's always fun to watch people when they're really good at something. You know, it doesn't matter what it is.
Yeah, it's fun to play too. I mean, I have a girl on my team for high school and she's like a D1 commit.
That's awesome. Do you think you'll maybe try and walk on somewhere or
I don't want to play volleyball in college just because I've been playing it for so long, and
Okay.
I think that I want to go to like a D1 school and like have an actual college experience. And I feel like playing on a team would just be so stressful.
Yeah, I mean, there are some benefits, like they really help you out in the academic side with making sure you
Yeah.
get, you know, certain classes that are beneficial and things like that. But that's good. Okay, with the time we've got remaining, do you want to do any inequality problems? Do you think that's going to be on your test?
Let me see. Hold on.
Something with a less than or equal to or greater than or something?
Yeah. I don't think any of those are on there. I think it's mostly like what we've been covering.
Okay.
There's one more problem we can do. It says identify the discriminant for the quadratic and then indicate the number and nature of the solutions, then use the quadratic formula to solve the equation.
Okay, do you have the equation?
Yes, it's 4x squared minus 12x plus 3 equals 0.
Perfect. Okay. So the discriminant comes from the quadratic formula, which I'm sort of shocked you don't need to know for this exam, because it's like right there as being like a, you know, part of this. The discriminant is just the part that I'm circling.
Yeah.
I won't try to spell it, but we'll go with its big letter D. So all you've got to do is figure out what is A, what is B, and what is C, and it comes from the equation here. So when you get these values, you just plug them into this formula here. So the only really way you can make a mistake is if you don't use parentheses when you substitute in. You really want to show those numbers in parentheses so that the sign, if it's negative, like it is in the case of -12, that you actually know that you're squaring -12 and not just 12.
Yeah.
So
Okay.
this is 144 minus 48. And you could subtract these and get 96, but what you care about is it greater than 0? Yes, it is. Okay. Because there's 3 options for the discriminant. It's greater than 0, it's equal to 0, or it's less than 0. So when it's greater than 0, and this is what you have to commit to your notes or memory or somehow get it down on the test right before it starts. If it's greater than there's 2 real solutions.
Okay.
So that's what your instructor's looking for. 2 and then the real. If they don't
Yeah.
see that, like, it doesn't matter what else you write. It got to be 2 and real, 2 and real. Okay, got that.
I think that covers it. I think that's all the questions they asked.
Yeah, so let me just fill in the rest of these here. One real solution, and then 2 imaginary solutions.
Yeah.
All right. Well, how do you feel? Do you feel prepared for the exam? Do you feel like if you took it right now, do you think you would get an A?
Yes, I feel very prepared. I think
Okay.
this is like it's not like it's super easy, but I think it's more basic things kind of.
So this is an opportunity for you to say, okay, this is the preparedness that I need, whether it's a math class or a college class someday down the road, this is how you got to want to feel going into an exam.
Yeah.
A lot of times the stress is just because you're like, yeah, I'm not prepared. I have no idea. But, just like when you're playing a sport, I mean, when you've done the practice and you put the time in, like it's exciting. It's fun. It's not,
Yeah.
I'm not going to say this is gonna be fun, but you're not.
Yeah.
So, well, are you okay if we end here for tonight?
Yeah, I think I'm good. Thank you so much.
Okay.
And I'll take the test and see when my next, I'll book something soon.
Sounds good. And feel free to let me know how you do by email or have your dad message me. And I look
Yes.
forward to helping you again the rest of the school year.
Thank you.
You're welcome. Bye now.
Bye.